Imagine you're at a movie theater where the screen is 24 feet tall. Here's the screen. And mounted on the wall, so its bottom edge is 10 feet above the ground, right? So 10 feet above the ground, there's a 24-foot screen. Suppose also that the floor is perpendicular to the wall holding the screen. So this floor is at a right angle. Now that's not normally the case, right? Actually, movie theaters, the seating goes up. And we could do that. It's just harder math. So we're just making it simple. Just suppose it's flat ground. You could do it with theaters going up. It's just more complex than we really want to do right now. So just say flat ground. All right, depending on where you sit, the movie screen takes up a different angle in your visual field. Consider the angle whose vertex is at your eye, with one side connecting to the top of the screen and the other side to the bottom, right? So this is your eyeball. It's going to the top of the screen and the bottom. That's your viewing. This is your viewing angle. In the image below, the seating position of the viewer is shown as a dot on the horizontal floor. You can interact with the image by clicking and then dragging the viewer's position. As you move the viewer, their distance from the wall and the viewing angle of the whole screen will be shown at the top of the image. Let me show you. Let me go back and move that around. Oops, that's not the right thing. There it is. Yeah, so watch when I move that thing. So as I move it closer, see that viewing angle? Gets really, if you're sitting right there in those front row seats, those ones nobody wants, you hardly have any viewing angle. Look how tiny your angle is. Go back here, see your angle grow? And now, oh, now it's shrinking. Getting back too far. It's a tiny viewing from the very back of the theater. It's a tiny viewing angle again. See that? Your angle from the top of the screen to the bottom, right around there. See, it's already right around there. It looks like your viewing angle is best. What does it say? Viewing angle is 31 degrees. That you have 31 degrees of angle, that you have the most viewing angle when you're about 26.5 feet from the wall. Whereas if you get closer, oh no, that's better, huh? 32, 33, my mistake. Okay, well, then it goes down again. Yeah, so right around there, 30, 33.06, right around 18.5 feet, you get the biggest angle of viewing, 33 degrees. 18.5 feet. So anyway, um, so that's the idea. So depending on where you sit, you get more or less viewing angle. Notice that when the person sits far from the wall, the viewing goes small. As they move closer, it increases. Too close, it'll decrease again. Right. Suppose the person is sitting X feet away from the wall. Express the viewing angle in radians of the screen. So this is the setup. On another problem, we'll finish it. So we're just going to set this up. We're trying to find what's the best place to sit in the movie theater that'll give you the biggest viewing angle. So they said, again, they said, suppose a person is sitting X feet away from the wall. So we're going to say this down here. Oops, didn't have a tool on. That right there. That is X. How far away from the wall you're sitting. So what's the best spot? Well, we're actually not going to finish that. We'll finish that in another problem. But here, let's just get a formula for theta, your viewing angle, in terms of X. And your viewing angle is that angle right there, right? An angle is an opening between two straight lines. So we have the straight line where your eyeball goes to the top of the screen and the bottom of the screen. And so the amount of opening between those, that angle is your viewing angle. It's the angle from, let me see if I can do it with a tool. No, wants to make it straight, whatever. It's the angle from there to there, right? That's your viewing angle. Well, how are we going to get that? Well, your viewing angle is actually made up of the overall angle up to the top, call that theta 1, minus the little angle on the bottom. I didn't leave enough room here. Let me try again. Okay, so let me try again. So I'll make this little angle here, theta 1, whatever you call it, theta 1, theta 2. And that one, theta 2. And so basically, the viewing oh, angle theta is equal to theta 2 minus theta 1, isn't it? So you're right, theta 2 goes from the ground all the way, and Theta 1 is just up to the bottom. So the difference between them, theta 2 take away theta 1, is theta, our viewing angle. So our viewing angle theta is the difference in those two angles. Okay, so we got to find those two angles basically. So how do we do that? Well, this is a right triangle. So you should be thinking about SOHCAHTOA. Remember your trig lessons? SOHCAHTOA. Remember that? Sine is opposite over hypotenuse, cosine's adjacent over hypotenuse, tangent's opposite over adjacent. So we have a couple of right triangles. We can take them one at a time. I can take, let's do the bottom one down here first off. Let's take this little bottom one. Just go up to there. Boom. So there's the little one with the, theta 1 angle. So here's the right angle. This side's the hypotenuse. This side, here's theta 1. And so this is the opposite side, and this is the adjacent. Remember how that works? From your angle opposite, that's the opposite side. Hypotenuse is always across from the right angle. So this must be adjacent. Okay. And so what do we know? Well, we know the adjacent on the bottom. This is x, right? That's just the bottom part. I just grabbed that little triangle and moved it over there so you can see it clearly. That's x on the bottom. Okay. And I know this right here, this is 10. They're telling me right there it's 10. Okay, so I know the opposite, I know the adjacent. What trig function involves opposite and adjacent? Tangent. Tangent. So that means the tangent of theta 1 equals 10 over x because that's opposite and that's adjacent. That's sloppy writing. That's adjacent, right? Tangent is opposite over adjacent, opposite over adjacent, opposite over adjacent. Okay, now we need to, what are we trying to solve for? We're trying to solve for theta 1. How do you get theta 1 alone there? What do you do? You do inverse tangent of both sides. That's what gets that alone. So then theta 1 is inverse tangent of 10 over x. Inverse tangent of 10 over x. So there's theta 1, inverse tangent 10 over x. Okay, now how do we get theta 2? Well, same kind of thing. It's just a whole triangle, right? We're gonna go, okay, let's put it here. Oops, I thought my tool was on. It's not. Just let's do the whole triangle. So we're gonna go right. Got to come down a little, cut a little bit off of that because we don't have room. And then like so. So and this is theta 2. Right there, right angle. So this is the opposite side again. This is the hypotenuse. This is the adjacent. And again, the adjacent is 10 because, no, it's not 10. It's x. It's x because it's the bot. Oh, that was not good. I wish it had not done that. There we go. Okay. This is x down here, right? This is x. And the opposite is that whole thing. Here's the whole side, which is 24 plus 10 equals 34, right? For theta 2 is the whole angle. The opposite is the whole side, 34. The adjacent is the x. So again, that's tangent. So we go, oh, yeah, yeah, yeah. I'll just crank it out over here again. So, well, you could just, well, I'll do it over here. So tangent of theta 2 is opposite over adjacent is 34 over x, right? Because that's opposite and that's adjacent, right? So for the whole triangle, theta 2 is the angle for the whole thing, right? You with me? So theta 1 is just the angle of the bottom triangle. We did the bottom triangle right here. Theta 2 is the angle for the whole triangle. So the opposite is the whole thing, 34. The adjacent, again, is x. And so now we can just go, all right. inverse tangent, because we're trying to solve for theta 2. Inverse tangent, cancel that out. So theta 2 then, theta 2 is the inverse tangent of 34x. So put it right here. Inverse tangent of 34 over x. And so there is the formula. Our viewing angle is theta 2 minus theta 1, inverse tangent of 34 over x minus inverse tangent of 10 over x. That's the setup right there. So then on another problem, we'll say, okay, now that you know that that's the angle, it depends. So that depends on where you're sitting, how far away you're sitting. That tells you your viewing angle. It's the inverse tangent of 34 over x minus the inverse tangent of 10 over x. That gets you theta 2 minus theta 1. Theta 2, take away theta 1, gives you your viewing angle. So now we're going to say on another problem, we say, okay, now maximize that. We want the biggest viewing angle possible. Find the x value that'll do that. So then you know what we'll do. We'll take the derivative and we'll set it equal to 0 and we'll solve for the x value that will actually give us the best viewing angle. So very important application for all kinds of things with optics and sighting and sights and computer applications that control all these kinds of things in many areas of life. So there we go. There's the setup for finding the best position. How far back? What is X? How far back do you sit from the movie theater screen to get the maximum viewing angle? And there we go.